Right now, we are trying to understand how our sun interacts with what's outside. And once we get outside, we will, for the first time, be able to determine how many cosmic ray particles are out there trying to get in. We'll for the first time, be able to determine the magnetic field which is out there, which has come from the explosion of supernovae 5, 10, and 15 million years ago, and created the medium which currently surrounds the heliosphere.
When NASA's AI failed, humans rescued a 47-year-old spacecraft. In the vast silent darkness of interstellar space, over 15.6 billion miles from Earth, a tiny spacecraft launched in the 1970s suddenly went quiet. After nearly 5 decades of near-perfect operation, Voyager 1 began transmitting unintelligible gibberish, a stream of ones and zeros no one could decode. NASA's most advanced artificial intelligence systems were quickly brought in to fix the issue, but even the best machine learning tools on Earth were baffled. It wasn't until a small team of veteran human engineers dusted off 1970s-era manuals and ancient code that the real breakthrough happened. Against all odds, they brought humanity's most distant explorer back online, proving that when machines fail, it's still human ingenuity that shines brightest in the final frontier. A signal gone haywire. In November 2023, NASA engineers noticed something strange. Voyager 1 was still in contact, but the data it was sending made no sense. It was like trying to have a conversation with someone who understood you, but could only reply in broken, unreadable gibberish. Radio contact remained intact, which meant the spacecraft was alive, but its engineering and scientific data had turned into nonsense. Think of it like the probe had developed space-age aphasia. It could hear Earth, but couldn't form coherent replies. Imagine trying to fix a 1970s computer over the phone with someone 15 billion miles away, said Voyager project scientist Linda Spilker. Now imagine each exchange takes 45 hours to complete. At the time, Voyager 1 was gathering groundbreaking data from the interstellar medium, the mysterious space between stars. It had recently detected a faint plasma hum, offering rare insights into interstellar gas, and now, all of that was inaccessible. When AI hit its limit, NASA immediately turned to its advanced AI diagnostic systems, technology that had worked wonders on the Mars rovers and other missions. These tools analyze vast databases of past spacecraft issues to spot patterns and recommend solutions. But Voyager 1 posed a unique challenge. Why couldn't AI fix it? No precedent. Voyager 1 is truly one of a kind. No other spacecraft has operated for 47 years or traveled this far from Earth. Extreme delay. Each message takes 22.5 hours to reach the spacecraft, with another 22.5 hours for a response. That's nearly 2 days for every test. Outdated tech. The probe's systems predate modern computing. It's alien territory for I trained on contemporary technology. But most critically, this was a problem that required imagination and creative thinking, skills AI still lacks. As NASA's chief AI officer David Salvagnini put it, AI isn't accountable, the human is. The human fix. For 5 long months, NASA's engineers dug into old code and telemetry looking for clues. Eventually, they zeroed in on the issue. Roughly 3% of Voyager 1's flight data system, FDS memory, had been corrupted. A single failing chip was responsible for storing essential software, now scrambled and unreadable. What caused it? Possibly just wear and tear from 46+ years of space travel, or maybe a cosmic ray, a high-energy particle from deep space, struck the chip and corrupted the data. And now, the mission team had to figure out how to bypass that chip remotely with a 1970s computer and no hardware replacement possible. Here's what they did. Moved the corrupted code to a different memory area, broke it into smaller chunks to fit into available memory, rewrote each segment so the whole program still worked, redirected all parts of the system to find the relocated code. This was an intricate, high-stakes operation, like doing brain surgery blindfolded with a 45-hour delay between each move. But on April 20th, 2024, Voyager 1 began sending back clear engineering data again. By June 13th, all 4 of its science instruments were back online, working like nothing had ever gone wrong. Voyager's legacy of human ingenuity. This wasn't the first time humans had to step in where machines failed. In 2022, Voyager 1's attitude control system began misrouting data through a non-functional computer, corrupting the output. No automated system flagged the bizarre detour, but human engineers figured it out and rerouted the data manually. Even earlier, in 2017, NASA reactivated thrusters that hadn't been used since 1980. These tiny engines had to be carefully warmed up before firing, a process that involved technical finesse and creative strategy. Again, humans did what no AI could, a miracle of deep space engineering. Let's pause for a second to appreciate how truly incredible this spacecraft is. Distance, 15.6 billion miles from Earth. If you drove that far non-stop at highway speed, it would take over 31 million years. Speed, 38,026 miles per hour, 17 kilometers per second. Memory, just 69.63 kilobytes, less than a single modern email. Power, 267.9 watts, about as much as 4 light bulbs. Launch year, 1977. That's before the first Star Wars movie came out. And yet, it's still exploring the space between stars. No other spacecraft has ever done that. The golden record, a message to the stars. Voyager. 1 isn't just a scientific mission, it's also a time capsule. On board is a 12-inch gold-plated copper disc, known as the Golden Record. It contains greetings in 55 languages, music from Bach to Chuck Berry, and sounds of Earth, thunder, laughter, birdsong. It even includes a message from then U.S. President Jimmy Carter. It's a message to anyone, or anything, that might find it. Carl Sagan, who led the record's creation, said, "The launching of this bottle into the cosmic ocean says something very hopeful about life on this planet." What Voyager taught us. Since launch, Voyager 1 has transformed our understanding of the solar system. It discovered Jupiter's faint rings and volcanic activity on its moon, Io. It revealed Saturn's intricate ring system and explored its moon titan. It captured the iconic pale blue dot photo, showing Earth as a tiny speck from 6 billion kilometers away. And in 2012, it became the first human-made object to enter interstellar space. It showed scientists that the region beyond our solar system is not a void, but a dynamic, turbulent environment shaped by solar winds and magnetic fields. Humans plus AI, a team, not a competition. This isn't a story of AI failure, it's a story of collaboration. I can process data faster than any human. It can spot patterns in terabytes of information and flag anomalies we might miss. But when things get weird, when a 47-year-old spacecraft starts acting up in a way no one's seen before, we still need the creativity, intuition, and experience of human engineers. As NASA scientist Giada Arney said, AI helps take the load off, but humans still need to check the results. And if this Voyager 1 story inspired you, check out our playlist on the greatest space missions ever, linked in the description below. We post deep dives into black holes, alien worlds, space tech, and more, every single week. So, subscribe now and become part of our growing cosmic community. Until next time, keep looking up.